Okay, so welcome back to part 2 of the XYZ scanning drill core Macrocore tutorial, where we are taking multi-dimensional scans of our drill core samples. So we're integrating all axes, the x-axis for focus stacking, the y-axis for down core panning, and the z-axis to capture the width of the overall drill core itself. So in the last video, what we did is we showed you how to set up the system and also capture all of the data, and now what we're going to do is go through and process this data. So first thing you want to do is go to the folder where all of your images were stored. So again, this is the tutorial video, and we're going to go to Macropod Macrocore images, XYZ scanning, and open up that folder. So first thing you want to do is just have a look at all the images to see what happens. Sometimes there might be something that maybe got out of whack. You just want to make sure that all of your photos here are in the right place and going to be processed correctly. So already here, I can just kind of notice that it looks like I forgot to delete 2 test images we took. You can see those right here. So what we're going to do right off the bat is we're going to take those 2 images and we're going to delete them. It's clear we don't need those 2 images. Okay, so one of the things that I notice when I look at this folder is that there are way more images in that first folder than there should be. And what that tells me is that some of my test images were still in here. I never deleted those before we got started. And that's one of the things you want to go ahead and do now. But there's also something else that we can do here. Just kind of use our intuition for a second and realize that the next batch of images, when the camera moved down core, we actually still have the entire corner of the sample. So this is sort of overlapping information. We actually don't need any of these images. And if just again clarify and point out what I'm doing here is that first folder. Sometimes it's going to contain the correct amount of images. Sometimes it's not. If these images are important, you want to just separate these out, call it image or folder 0, and then just remove them from the rest of the batch. That way we can separate out all the other images the same way we did in the XY stacking and stitching video. And again, here, the reason why I'm deleting all these is these were probably test shots, and then we actually started the imaging process, so it captured 8 images plus our test shots. But the reason why I'm deleting them is we really just don't need them, because you can see that all the information in this frame is visible in the next frame. So why stack it when it's already going to be captured over here? So let's go ahead and we're just going to delete all of those photos. There we go. And now one thing we can do is just make sure that all of our images line up. So we have 1, 2, 3, 4, 5, 6, 7, 8 images, all of the same frame. We're going to focus stack those. And as you move on, you can see that there's 8. The next row, we have another 8. The next row, we have another 8. And you can just go all the way to the bottom and make sure that this is consistent until the very end. And look, we do have it's good that we went down here. We have one little image over here, which again might have just been a test image that we're just going to delete and get rid of. So we're going to delete that one. And again, the last one in the batch, 1, 2, 3, 4, 5, 6, 7, 8. So that's perfect. So now and if ever you need help visualizing this, you can see how my window's set up. If I just sort of slide it and the images get overlapped, it's a little harder to see. But if you just sort of make it so that the window is exactly a multiple of the amount of photographs you took, then it's a lot easier to just see what you're doing. And again, likewise, you could just take it right over to your factor of 8 images, just like that. Okay, so again, what we want to do is open up FolderX. FolderX is an automated tool that allows us to separate out those folders. So we're going to select this folder, the 2019-11-27, which is where all of our images are stored. Go down to drill core images, XYZ scanning, and 2019-11-27, and press OK. Okay, so now we have our folder. We're going to separate these out by amount, so every 8 photographs, 8. And then you want to just select the folder where you want these to be saved. And we'll just click on overall XYZ scanning, press OK, and now that's where all these images are going to be saved. So from this point, you can go back to the FolderX software and press split, and it's going to automatically separate out those folders. You can go back to XYZ scanning, and now you can see each folder contains 8 images of a single focus stack. Okay, so we'll delete this initial folder. And now what it's time to do is go to Zerine Stacker and make sure that all these images are stitched together so that we're getting a high clarity output image that's completely in focus on every single frame across this core sample. The following step after that is to just simply merge them together. So we're going to do, again, open Zerine Stacker. We're going to go back to that folder. We're going to, oh yeah, that's right. So instead of dragging and dropping, what we're going to do is we're going to batch process these. So that way it just sort of takes care of everything for you. So we're going to go to batch. Show batch dialog. We're going to add a project. Oh, sorry, not a project. We're going to paste folders. Okay, forget that. What we're going to do is we're going to take all those folders and make it simple on ourselves. We're just going to highlight them all, and we're going to drag them to that window. 147 total frames. Place that there. We're going to change where we're going to be saving the output images. So we don't want them to be saved in the exact same folder that they're currently in. We want them to be saved into an overarching folder that houses all of the photos. So we're going to go to this PC, back desktop. Okay, find the tutorial, video tutorials section, Macrocore, XYZ scanning. Oh. That's the video tutorial. We want images, XYZ scanning. There we go. And we're just going to save our images right here. So we're going to hit save. Then what we want to do is add our stacking option. So align and stack all PMax. That's going to ensure that all images are stacked. And from here, we're ready to get started. So we're going to hit run all batches. What I'll do is I'll let this process on its own. When I just close, close this window so that you can see what's happening, and we'll just start to film. I don't know if we're going to film the entire thing, but we'll let it film for a good portion just so you can see what the software is doing and how it's going to process. But already you can see the types of detail we're going to see in this core. I'll just take this up to 100%. So over here, the texture of the one getting overlap. We're getting an entire image that's completely in focus, and look at our quality there of just one frame. So when we stitch all these together, you can imagine the overall quality we're going to get with the entire core sample. Okay, so let's just go back to fit window. Again, we'll speed this up for you so you can see how this is going to work, and we'll reconvene when it's time to stitch together the output photographs. Once the batch processor is all done stacking the images, what we want to do is start to merge them together. So we don't need Zerine Stacker anymore. We're going to close out of that, and we're just going to navigate to the folder where our final output images are, and we're going to begin the process to start to merge together all of this data. So in the XY video, the one where we combined focus stacking with Y panning, I showed you how to photo merge using Photoshop. Photoshop's fantastic, but when you have a lot of high resolution data like this, it's not as good as aligning the photos as some other software programs. So if you're going to do XYZ scanning, we recommend that you use Gigapan. It's a very low cost software. I think it's about $100 for a license, and you can use the Gigapan Stitch EFX file. And the way it works is initially you'll add all of your final output images. So we're going to select and highlight all of those. Press open. It's going to pull it into this window over here. And you can see that it's starting to look a little funky. We have 4 images and then all of a sudden it resets, and that's because it's programmed right now to do columns and then rows. You can see here, that's the default. But the way we captured the core is we did rows and then moved down to start another row. So rows, then columns. So we want to change it to rows down, and then and that's going to reset our images. Now, there's also other options here. So there's a vignette correction. We don't really have any vignetting. That's all taken care of in the system. And there's other things, but here you can see Mercator projection instead of spherical. And that just means if you turn on Mercator projection, what's going to happen is it's not going to sort of distort the final image in any way. You're just going to leave it as a block. And that's what you want, because these images are used in analysis to measure things like porosity, grain sizes, or just other mineral composition, chemical composition. You don't want any distortion, so you just want to make sure that Mercator is on. So we'll press OK, and now you can see our images are properly aligned, but we only have 5 columns. So it's pretty intuitive, the software here. We just make this larger, and we're going to change the number of columns. There's 20 photos per row, so we're just going to take this number up to 20. So we have 20 columns, and now you can see all of our images are properly aligned with one another. And the next step after this is simply to do save selection and stitch. And then you can save where it's going to be. So we'll call this limestone drill core. And we're going to save it in the same location that all of our images were before. So we'll hit save, and this is going to start to process. The good thing about this software as well is it doesn't take very long. So it's 12:11 p.m. We'll let this process for a little while. But my guess is it's not even going to take 10 minutes to finish putting all this data together. So this is by far and away the simplest method to process and handle very high resolution data. But there are other ways. Again, if you're probably going to have Photoshop active. And one thing you could do to make the process a little easier is because the images, each one of them are so high in resolution, you could actually do it a little less resolution. And in case you don't know how to change the resolution of an image, I'll show you how to do that right now. So you want to open up just one photograph, one of those frames in Photoshop. And what we're going to do is we're going to apply a change to all images using Photoshop so that all these images are half the size of where they currently are. And that way it just speeds up processing. But again, if you don't want to compromise the quality of your data, again, it's better to use Gigapan like I am in the background. But what you'll do here is you'll go to Window, and you want to make sure that your history is recording. So by doing that, you're going to navigate down. Let's see here. You want to click this history here. That shows your selection over here, and then also your actions dialog. So Window, you want to make sure actions is selected. That one already is selected. So you can see down here just below layers, this is where our information is. And what we want to do is create a new action. So we'll call this reduce file resolution. And we'll hit record. And this is automatically going to start recording, and it's going to place it in a folder here. So now any action that we do in Photoshop is being recorded. So we're going to change the image size because it's very large. Each image is almost 100 inches wide. So let's just say we're going to call it, let's take it down to 20 inches. Press OK. Whoop, I hit cancel. Let's try that one more time. 20, press OK. And now you'll see the image is much smaller, much more manageable, much easier for Photoshop to handle. So that's done. We've just recorded an action. You can come down here to actions and press stop. And then what we can do is, let's say instead of saving this, what we want to do is apply it to all of those images in that folder. So what you want to do is go to scripts, file, scripts, and image processor. You want to select the folder that contains all of those images. So we'll go back to desktop, video tutorials. I know we've been through this a lot, but we'll go back to the drill core images. Here we are, XYZ scanning. And we have all of our files down here. And it's going to automatically select those. So you press OK. All of those images are going to be located in there. Save all of your output images as a JPEG, and then you want to run an action. And in this case, the action is going to be reduce file resolution. So you just click reduce file resolution, and then you'll press run. And what that will do is it'll take all of these photos, and that action where we decreased from 88 inches down to 20 inches along the long axis of the photo, it's going to create a subfolder down here, and it's not going to overwrite these images, but it will create a folder containing files that are much more smaller and much more manageable. And then you can process that data. So that's one method of getting around the stitching problem. The other is to just stitch manually. So we're gonna close. Whoops, I hit run. We are gonna Okay, so it's actually going through and it's going to reduce these images. One thing I'll do is I'll just, we will quit Photoshop real fast. Oh, we're going to have to let it process through. So one of the things I did notice is it saved in file folder 19, I think is the one that we were doing. So you can see what happened here. It took these images. That's the one I accidentally selected. And it created a JPEG of smaller file sizes. And that's how that function basically works. So sorry about that. It was some slight confusion. We'll just delete those. But yeah, that's one way you can do it. It'll create a new folder. It'll make all these images smaller and much more manageable in order to process. But again, this software back here is going to do the trick. So the other thing you can do is simply create a new artboard. And you can merge all these together automatically, so manually. I don't recommend this, but if quality is very important, then it's an option for you. So what you can do is create a new artboard, and then you can refer to these photographs and simply build up the entire core sample on your own. That way you don't rely on the computer's processor to try and handle all of this data. So we have one image there, and then we can go move on to our second. Move our second image over. Oh, we just need to place that file. Yep. And we'll take our second. Basically, you'll just overlay it right there. And you'll keep doing that until the entire core sample is built out. And once you have all images, so all 20 by 6 photographs, you'll go back to layers. You want to click on them. You want to rasterize those layers. And then you'll go up to Edit, Auto Blend, and Panorama and press OK. And that will blend together the images manually. So that's how you would do a manual photo merge. But again, a time-consuming but effective method at preserving clarity, resolution, and overall alignment for proper analysis. So those are 3 quick methods just to show you while this is working in the background. But what we'll do is we'll continue to let Gigapan merge these images together, and then we'll reconvene as soon as it's finished, and then we'll show off the final result. Okay, so I walked away from my desk for a minute, but just now back. So you can see we're about 12 minutes in. Most of the stitching is already in place. Now what it's doing is it's going through and just blending together each of the images, but you can see here we've got a very high quality result with very little to no artifacts whatsoever. And you can see if you line up that top edge, even though it appears when we're out, this is really just an effect of trying to make it easier on your eyes to visualize. It kind of looks like it's concave, but you know, if you were to actually zoom in and line up that top part of the core, you can see how straight it is, and likewise with the bottom side. So there is no warp. This is a Mercator projection, so there's not going to be any warping in the core sample whatsoever. So now this is a final high quality image captured at 1x optics with a 26 megapixel sensor. So this is going to be about 10 times the quality of what we were able to achieve before. And all in all, it's not very difficult. The whole process is automated. The entire scanning process is going to take about an hour. And then again, as you can see here, once you merge together the images in ZrainStacker and then merge them here, it's about another hour. So when do you want to use this approach? This approach is best used if you have very high quality analysis you need to do. If you need porosity of the entire core sample, for instance, if you need grain size or chemical data, or just want to visualize relative percentages of certain minerals within a core sample, then this approach is very good if you're doing it for presentations, you're raising investor capital, or so on. But generally, our recommendation is always to take a high quality contextual images using X stacking and Y panning, which is much faster. And then if you have details that are higher magnification, like we have here, then it's better to just focus in on the area of interest and then capture a high quality image using a different optic. And that's always been our approach. It's much more efficient, but one of the things that's really nice about this is that you have the flexibility to capture any type of image you want. So something that's high quality, and very efficient to something that's very high in quality, but again, less efficient in terms of overall capture time. But here you go. So this image is 90% complete. It looks like it's going to take about 15 minutes. We should be almost at the end, and then once this is finished, what we'll do is we'll just upload it to the Gigapan server, which is where we have the other 2 Final Core images stored, and then you can do a side-by-side comparison of all 3 using this tutorial page just to see and evaluate the change in quality for yourself. So that really is the end of the XYZ scanning tutorial video. And I want to thank you guys for watching. I hope that this was informative. If you have any questions, don't hesitate to email us. You can contact us at info@macroscopicsolutions.com. And then what we'll do is, we'll get back to you as soon as possible. So the next tutorial videos we're going to be making are going to be about our petrographic analyzer, which is going to show you how to capture images of thin sections, so geological thin sections and biological slides using plane and polarized light. So once again, thank you very much, and have a great day, and thank you for choosing Macroscopic Solutions.